Okay, this is practice number 11. You should have done the bottom two questions. If you've not yet done the bottom two questions, please pause the video and do those before you see any more of the explanation. Energy. A 7 kilogram box falls down a 2-meter shelf. At what velocity does it hit the ground? So the given variables, the 7 here is the number of kilograms in the mass m, and the height is 2 meters. Please make sure you only have the m and the h, not the words mass, not the word height. If you wanted to have a y there instead of the h, that's fine. The desired variable is v for velocity that hits the ground. Now this is labeled as energy, so that should give you a hint that you're going to be using the ideas of kinetic energy and gravitational potential energy. You could write off that as the beginning raw equation. The beginning gravitational energy equals the ending kinetic energy, or you can do the phrase for each one of those, mgh for the u and the 1/2 mv squared for the kinetic. Substituting things in, 7 for the m, 9.8 for the g, the height of 2, again the mass of 7, and we're solving for the v. Do your algebra correctly and you should be getting 6.26 meters per second. Don't forget the meters per second. If you didn't write it down, please do so now. Last one. A student takes 2 seconds to get an 8 kilogram box up to a speed of 2 meters per second. Find the student's power output. So the given variables, t is 3 seconds, m is 8 kilograms, the final velocity is 2 meters per second, and it's implied here, it's not stated strongly, that it starts off at a standstill. I really should rewrite this question to say that it starts off stationary to make that really obvious. So on an SLO, I would make sure that was clear. Okay, the desired variable is the P, capital P, for the power output. And we're going to start off the same way with the idea that power is a change in energy over time. But in this case, the energy is kinetic energy. So on the top, we're going to have 1/2 mv squared. In the previous sheets, 9 and 10, we had the change in energy being gravitational potential energy. So at the top we had mgh. Things were being lifted to a higher elevation, a table or a shelf. In this case, we're speeding something up. So substitutions, 1/2 8 for the mass, 2 for the velocity, divided by the time of 3, and you should get 5.33, and it's still watts. Power is always in watts, capital W.